Welcome to this explainer. Today, we're diving into a massive, frankly mind-bending mystery at the very intersection of AI, cognitive science, and physics. We're going to explore the physical origins of the boundary between self and the world. This is part one of a two-part series, and we'll be looking specifically at the thermodynamics that existed before the free energy principle, and how this crucial boundary, something called a Markov blanket, first sparked into existence.
Here's our roadmap to crack this mystery today. We'll start with the boundary paradox, then move into the physics of boundary formation. After that, we'll look at a really cool visualization called the Chladni toy model, discuss FEP without consciousness, and finally look at what comes next.
Let's kick things off with part one, the boundary paradox.
There is a logical trap sitting right at the bedrock of standard cognitive science, and honestly, a lot of researchers just tiptoe around it. In standard models of neuroscience and AI, the free energy principle, or FEP, explains how systems survive by minimizing surprise and maintaining their boundaries. But this begs a giant, glaring question. Which came first? Did the boundary create the conditions for the free energy principle, or did the free energy principle somehow create the boundary? It's the ultimate chicken and egg scenario.
Before we go any deeper, we need to pin down exactly what this boundary is. In the scientific literature, it's called a Markov blanket. Think of it as the absolute statistical and physical wall that separates the inside of an entity from its outside environment. The Markov blanket is absolutely essential for any system to exist as a distinct thing, whether that's a single cell, a human brain, or an artificial intelligence. Without it, you literally bleed into the environment. You just don't exist as an individual entity.
But here is where we hit a massive wall. In the standard free energy principle framework, the boundary's existence is just assumed. It's given as a pre-existing axiom. But if we say, the free energy principle works to maintain the boundary, we fall straight into a tautology. If FEP needs a boundary to exist in the first place, we absolutely cannot use FEP to explain how that boundary got there. It's completely circular. To explain the true origin, we have to go deeper than standard biology.
And that brings us to part two, the physics of boundary formation. To escape our paradox, we have to strip away biological assumptions and look at pure, non-equilibrium thermodynamics and information geometry. And it all boils down to the single thermodynamic condition equation. Now, I know it looks a bit intimidating, but stick with me. It's K sub B times delta R info is greater than E segregation over T. This beautifully illustrates the exact physical moment a boundary spontaneously forms out of uniform, empty space. Let's break down what these pieces actually mean.
You can think of this equation like a cosmic balancing scale, weighing profit against cost. On the right side, we have E segregation divided by T, which is temperature. This is the entropy cost. Think of it as the literal energy rent required to physically build and maintain a membrane separating the inside from the outside. On the left side, we have K sub B, the Boltzmann constant, multiplied by delta R info. That delta R info is the information curvature difference. Basically, it's the information profit you gain from having a gap between high-density internal information and a chaotic external environment.
The absolute key to all of this is that greater than symbol. The moment the information profit on the left becomes strictly greater than the physical entropy cost on the right, boom, a non-equilibrium thermodynamic phase transition is triggered. A physical soft Markov blanket is instantly locked into place. The universe just mathematically decides that it is cheaper to build a wall than to remain uniform.
All right, let's move to part three, the Chladni toy model. Abstract physics equations can be a bit dry, so let's visualize this with something incredibly cool called Chladni figures. If you sprinkle regular sand onto a metal plate and vibrate it at specific frequencies, the sand magically arranges itself into these beautiful, intricate geometric patterns. What's truly fascinating here is that these patterns aren't just art, they represent actual physical boundaries forming in real time, mirroring the exact math we just talked about.
Let's look at the actual mechanics of how this happens. First, the metal plate vibrates according to what's known as the Kirchhoff-Love equation, which creates an invisible landscape of high and low energy. Second, the totally mindless sand particles just move blindly down this potential gradient. They are literally being pushed away from the violent shaking. And third, the particles settle at the nodes, the quiet areas of zero vibration. By clustering in those quiet zones, the sand draws stable boundary lines right across the plate.
Which leads us perfectly into part four, FEP without consciousness. This pure physics completely reframes our understanding of boundaries and intelligence. Let's be very clear about something. Mindless sand has absolutely zero intent, no consciousness, no predictive ability. But mathematically speaking, the sand particles act as action variables. The plate's vibration acts as sensory input, and settling at those quiet nodes mathematically equates to finding the minimum state of prediction error. The collective behavior of this sand is perfectly isomorphic to the complex math of the free energy principle.
This brilliantly highlights the sheer overwhelming power of physics over biology. At the micro level, individual grains of sand are totally blind. They know nothing. They are just following physical forces with zero computation. But at the macro level, the entire system behaves mathematically exactly as if it is actively minimizing free energy to maintain a distinct boundary. It looks for all the world like a cognitive entity, but it's really just pure thermodynamics.
And this brings us to a massive paradigm shift. The ultimate takeaway of this explainer is that the Markov blanket, the boundary between self and world, is not some magical prerequisite that was just handed to biological life. It is the inevitable result of a thermodynamic phase transition. When that internal and external information curvature difference finally exceeds the maintenance cost, physics doesn't just suggest a wall, it spontaneously builds one.
Finally, Part 5. What comes next?
So, we have successfully solved the chicken and egg paradox. Physics builds the boundary first, and then the free energy principle takes over. But guys, this is just the beginning of the story. We've established a proto-model of a boundary. Because this physical structure is now locked in and stabilized by thermodynamics, FEP can finally act upon it. The system stops being just vibrating sand and starts becoming a self-updating entity. This sets the stage for something called Layer 3 geometric inheritance, the ability to actually structurally evolve.
Which leaves us with an incredibly provocative thought to end on. If mindless physics and simple math can spontaneously build a boundary out of thin air, how does the simple, unthinking structure eventually evolve into true, self-updating, hierarchical intelligence? We are going to answer that exact question by diving into the mechanics of Layer 3 geometric inheritance in Part 2 of this explainer series, so stay curious, and I will see you then.